So welcome to my channel. So in the previous video I have designed the flip-flop inputs and the output Z equation. Now I am going to find the next state outputs by using this truth table. So you know the D flip-flop truth table, there is present state Qn, so and input D. Okay, so 0 0 means next state is 0, 0 1 means 1, 1 0 means 0, 1 1 means 1. So from this table I am going to compare QA DA to QA plus 1 and QB and DB to QB plus 1, right? Okay, so here I want to compare first QA and DA, right? So QA and DA means what? 0 0. If it is 0 0 means what? If it is 0 0 means the next state is what? 0, right? Next, if it is 1 0, if it is 1 0 means the output is what? 0. Okay, next, if it is 0 0, if it is 0 0, again 0 only, right? If it is 1 1, so the output is what? 1. Okay, so actually, so whatever the q, because the qn plus 1 is equal to d, so characteristic equation already I have discussed in the previous video. So qn plus 1 is equal to d means whatever the d output is there, the same output will be appeared over here. Okay, you can check it. Okay, you can check also, the same output you will get. So 1 1 1 0, right? Similarly for qb plus 1, compare this qb and db, right? So see here 0 1, 0 1 indicates what? 1, so that is 1 is there now, so same 1 you will get. Then 0 0, so 0 0 means what? 0, so the same 0, because qn plus 1 is equal to d, in that is characteristic equation of D flip-flop. So okay, so whatever the D output is there, value is there now, so that will be appeared in the next state. Okay, so what you will get here? 1. Okay, here 0. So if you want, you check it. So 0 1, if it is 0 1, if it is 0 1 means the output is what? 1. So here 1 0 1 0. So these are the next state outputs. Okay, so from this, so you know all the values, that is input you know, the present state you know, then next state you know. So you can draw the output also you know, right? So you can draw the state diagram by using this state table. That is reverse process. Okay, already I have explained that is what from state diagram to sequential circuit in the previous videos. Here we are dealing with what? Sequential circuit to state diagram, reverse process. Okay, so from this state table I am going to draw the state diagram first. Okay, now I am going to use the states. Okay, 0 0 as one state, 0 1 as one state, and 1 0 as one state, and 1 1 as one state, right? Now I am going to use the 0 0 state. So here I am going to use a 0 0 state, for example. So this is one state. Okay, if 0 0, if 0 0 is there means input 0 means, if 0 0, just assume this one, if it is 0 0, if the input is 0, so where it will go next state? 1 0. So I am having 1 0 somewhere. So for example I am having 1 0 here. So for example 1 0. Okay, 1 0 is one state. So if it is input 0, if input is 0, so where it will go? Next state, that is 1 0. It will go 1 0, right? What is output? So output as 0, right? Next. Okay, if it input again, so next state, so here the starts with otherwise you just check it here. If input 0 0, this one, so first you just check this one and this one, right? So first complete one by one. Okay, first take the one state number. Okay, complete both input excitation 0 and input excitation 1. See here, input excitation 1, if it is 0 0, input 1 means where it will go? So next state 1 1, it will go 1 1. So I am going to use here 1 1 I am using, right? So I am going to connect like this. Okay, so this is what, if input 1 and the output is what actually? So what you will get? Output 1. So you will get 1 over here. Okay, that's all. So now the input 0 excitation is over. Okay, we just put a class mark over here. Next I am going to check the 0 1 state. So 0 1 state, here 0 1 state, if input is 0 means, if 0 1 state, if input is 0 means where it will go? 0 0. So now I am assuming here a 0 1 state is there. Okay, see, if input is 0 means it will go to 0 0 state. So if input is 0 means it will go. So if input is 0 means it will go to 0 0 state. What is the output? 0. So what is the output here? 0 1, right? Because already I told in the previous video, that is numerator means input and denominator means output, right? Next, come to here. So now this is over. Okay, so this is over, and come to 1 0. Same 1 0 for input excitation 1. For input excitation 1 means where it will go here 0 1, right? The same retain, it retains in the same state. Okay, it retains in the same state. That is, so input is 1. So what is the output over here? So that is 0 1 na? So what is the output? 1. You will get 1 output. Okay, so this combination also over, right? Next, come to 1 0 concept here. So 1 0 present state. So 1 0, if input is 0 means where it will go? Where it will go? That is 1 0. So it will retain in the same state. So it will retain in the same state. That is input is 0. This one input is 0. What is output? 1. So this is also over. Okay. Next, the same thing here. You come here. Here that is 1 0. Here 1 0. 1 0 is there, right? Here 1 0. If here 1 0. If it is 1 0, if input is 1, if input is 1, where it will go? 1 1. So if input is 1 means 1, so 1 1, and what is the output? Output is what? 1 actually, right? So this is also over. Then final one, last one, that is 1 1. Okay, if present state is 1 1, if input is 0 means where it will go? 0 1. Okay, 0 1. So where is the 0 1? Here. So I am going to make like this. Okay. Okay, what is the input? Input is 0 means, so what is the output? Actually, what is the output you are getting? 1. So 1, right? Okay, this is over. Okay, the last combination here 1 1. 1 1 for input is 1. 1 for 1 1. Input is 1 means where it will go? So here 0 0 will go. So it is 1 1 means, so it will go to 0 0. So what is the output here? 1 1. Okay, or otherwise you write here 1 slash, what is the output? 1. Okay, so this is the actual state diagram you are going to get from this circuit, right? Okay, now 0 1. Okay, so you just if you cross verification means you just do it here. So here 0 0 0 0, input 0 is there, and input 1 also there, right? So that is over. 0 1 0 1, input where is input 0? So for 0 1, input 0 is there, and input 1 is there. That is also over, because each state having 2 excitations. Then 1 0 1 0, just take 1 0. So input 0 is there and input 1 is there. So 2 excitation is over. Then 1 1. So input 0, where it will go? Here. Okay, then 1 1. So this is the state diagram for the following sequential circuit. Now you know the state diagram. Okay, this is what state diagram. You just draw the state diagram. You just draw the ASM chart. Now the one half part is over. This state diagram is over. We have to draw the ASM chart over here, right? So how to draw the ASM chart? So already I told. So ASM chart consists of what? 3 notations. One is state box, conditional box, and state box, decision box, and conditional box. So let me start with 0 0 first. So first what you have to do now? So first you just start with one state number, that is 0 0. So this is what I mean, one state box. So state box consists of what? 0 0 as one state. Okay. So state box entry path. This is the entry path, right? So here state name they have not given. So I have used only, that is state representation, right? Binary representation. So for this state box, so I am going to connect what? Decision box. This is the format actually. So you have to do first state box, that should be followed with decision box. Okay, here decision box is what? Based on the input condition. What is the input here? Where here x is the input. X is the input actually, right? X is the input and Z is the output. Okay, in the circuit. So what I told, in the decision box you are having 2 exit paths. One is, so if it is 0 means where it will go. If it is 1 means where it will go. So that is the concept over here, right? So if it is 0 means where it will go, and 1 means where. So now the state 0 0. If it is 0 means where it will go actually. If it is 0 means here, if it is 0 means input 0 means it will go to 1 0. So what I am going to do, if it is 0 means, so put one condition followed by always this decision box is followed with conditional box, output box actually, right? So in this always you just put automatically, so one conditional box for this one. Okay, if this conditional box in entry path is what? Always the exit path of decision box is what? Entry of the conditional path. Okay, now here the what is the output here? Z. Okay, so if input is 0 0, input is 0 means where it will go? 1 0. So 1 0 means you just make one state box over here. So state box, this, because 1 0 is one state box na, so 1 0 is one state box. But what is the output over here? So output is what? 0. So z is equal to 0, right? Then the same state number, you just take same state. Now input is 0 is over. Input is 1 means where it will go. So input is 1 means, so it will go to 1 1. See here, check here. So 1 1. Direction is very very important. So now I am going to put one more state state box over here. So new state box. Okay, new state box. So here the state box number is what? 1 1. Okay, what is the output? Z is equal to 1. Okay, this is what? Now 0 0 state is over. Come to next 0 1 state or 1 0 state, whatever you want. So for example here 1 0 state is there na. First we just complete 1 0 state. So here 1 0 state. If 1 0 state, if the same thing we have to follow, that is one put one decision box over here, one decision box over here, and it has two exit paths, that is 0 and 1. It should be followed always with one conditional box. So you have to draw like this. So one conditional box you have to put. Okay, right? So if 1 0 state number, if input x is equal to 0 means, if input x is equal to 0 means where it will go? Same state. So you just draw like this, same state. Okay, connection. Okay, what is the output? Z is equal to, what is the output? Z is equal to 1. Okay, the same thing here 1 0. If input is 1, where it will go? 1 1 state. So if input is 1, so if input is 1, it will go, where it will go? That is 1 1 state. This is the entry path actually. So you have to give the entry path over here. Okay, entry path. This is the entry path connection, right? So what is the output? Z is equal to, so Z is equal to what? Output 1. Okay. Now this 1 0 state also over, 0 0 state also over. Then come to a 1 1 state. So here 1 1 state. If input is 0, if input is 0 means where it will go actually? So if input is here, if input is 0 means it will go to 0 1 state. So what you have to do now? So first make one condition box. Okay, first one make one condition box. It has two exit paths. So x. So make one one decision box and then followed with condition box. Right? So this is what? 0 and this is what? 1. Right? So 1 1 state, if input is 0, x is equal to 0, x is equal to 0 means it will go to 0 1 state. So 0 1 state. Now I am going to put one 0 1 state over here. Okay. So this is 1 0 1 state. Okay. 0 1 state. So what is the output here? Z is equal to, what is the output? 0 1 state. What is the output? Output is 0. Okay. This is Z 1 state. Next. If input for 1 1 state, for 1 1 state, if input is equal to 1, if input is equal to 1, so it's here, if input is equal to 1, where it will go? That is 0 0 state. If input is equal to 1, where it will go? That is 0 0 state. We just draw like this. Okay, so this is what input is. What is the output? Output is what? So here here is the direction now. So Z is equal to 1, right? Next, so now it is over. Then come to 0 1 state. So 0 1 state, again one state box is there now. So state box of what I told. So first the state box. So just make like this. Okay. So one decision box, conditional box is there. Z is equal to 0, and one state box. So this is the state box. So 0 1, right? So here you have to put one condition, one decision box x, and it has followed by 0 and 1 and one conditional box. Okay, so this is one conditional box, this is one conditional box. Okay, so 0 1, right? So see here, if 0 1, if input is 0, if input is 0 means where it will go actually? Direction, this is the direction actually. If input is 0 means it will come to 0 0. So 0 0 over here. So just connect like this. Okay, so this is the 0 0. Okay, connect like this. Okay, what's the output? Output here Z is equal to 0. Right? Okay, then the same thing here, Z is equal to 0. Then 0 1. If 0 1, if input is 1, where it will go? The same. It will retain in the same state. So it will retain in the same state. You connect in the same state. Okay. So what is the output? Z is equal to 1. Okay. So this is the basic procedure for drawing ASM chart for this state diagram. Okay. So what you have to do now, you have to think. Okay, just this is the flow. First state box is followed with decision box is followed with conditional box. From the output of conditional box, it should be given to state box again. Okay, see here, this is one setup. Okay, state box, decision box, then condition box. Similarly, state box, decision box, condition box, state box, decision box, condition, all state diagrams. Okay, this is the procedure for drawing the ASM chart for the given state diagram. So hope you understand this video and enjoyed this video. Please share, subscribe and like this video. Thank you.